So hey everyone, welcome to the session on In the Kitchen, a sprinkle of fire and chaos. So this is Sarna and Karthik, your host for this talk. So without any delay, I would like to welcome our speaker, Ana Margarita Medina, who is a chaos engineer at Gremlin San Francisco. She started her coding career as a middle schooler doing freelance work, went on to land paid engineering internships throughout high school and college, and eventually dropped out to work full time in Silicon Valley. Prior to Gremlin, she has also worked at Uber, where she was an engineer on the SRE and infrastructure teams, specifically focusing on chaos engineering and cloud computing. So, in case you have any questions, do type in the event chat or the Q&A section. And if you wish to interact with our speaker, please do raise your hand so that we can invite you on the stage. You can also post your questions or queries on the dedicated Slack channels, and I would be sending the links in the event chat in a while. So I hope you have a great learning session. So over to you, Anna. So I'll be playing a video in a while. Just a minute.
Hey y'all, welcome to my talk. Thank you Chaos Carnival for putting this remote conference together. Today I'm going to be talking about things that happen in the kitchen, the chaos, the fire, and I'll bring it back to talk about learning, and I'll touch base on what my favorite ingredient for building resilient cloud native applications is. First, I want to touch base a little bit on how did you all learn how to cook? Did you learn by watching? Were you someone that had to go and try a few recipes before you got a chance to learn them? Are you someone that just watches tons of YouTube videos on recipes that you want to give it a try? Or are you someone that needs to have feedback early and often to know how much salt that they're using? I know for me, I had to watch a lot of YouTube videos in order for me to get the recipes down, but at the same time, I'm also someone that needs that feedback often as I'm cooking, so I'm always trying all the food as I go. The question that I want all of you to start thinking about right now is, how do you learn? What are some of the best ways that you have learned? And this is not just about cooking. I want you to think about how is it that you go about learning distributed systems? How did you learn how to navigate the cloud space? Are you someone that has a specific way? Are you someone that needs to consume a lot of content, whether it's conferences, YouTube, videos, or just following tutorials? Or are you just someone that wants to go ahead and build and continue learning just by doing? And let's bring it back to this kitchen space. How do I learn how to cook? How do I learn that my food tastes good? How do I make sure that I'm cooking at the right temperatures and using the right ingredients? Well, a lot of it is about me cooking for others, because cooking for one is just not my forte. When I cook, I spend a lot of time tasting everything as I go, and a lot of that comes because I need to know if I'm headed down the right path, or I need to just throw away my entire plate and start all over again. For me, it's about that. I need to go ask for feedback. I need to learn how this is going. And I love cooking for others. For me, it's that pleasure of, hey, give me feedback on what I cooked, but also sharing that experience together. So yes, Anna, you're at a tech conference, you're at Chaos Carnival. Can we stop talking about food? Well, today I want to first touch base on some analogies that happen in the kitchen that we can kind of get a chance to learn. There is a lot of beauty in cooking, and that is because as humans, we get to learn a lot in this process. As I'm tasting everything that I cook, this is very similar to the way that I observe my applications when I'm running them on development, staging, or production. This is very similar to the way that you want to go ahead and do gradual rollouts of your applications and systems. You want to go get that feedback and observe as often as you can. And when I cook for others, In the cloud native space, this touches base on experimentation. You're trying new things. You're putting it out for your customers to just kind of let you know how all of that is going. And for me, it's that experience of the end user. My customers, the folks that eat my food, those are the ones that are going to let me know if my experiments are successful or not. And sometimes you need to just go ahead and burn your food in order for you to learn, hey, I shouldn't be cooking this protein at this temperature. And in this cloud native world, or when we talk about systems and applications, this is that moment where you go ahead and you look at those past failures that you have. You have to think about, what have I learned in keeping this application reliable for the last week, the last month? What are some of those incidents that my organization has gone through in the last 6 months? And you go ahead and you replicate those incidents. You start asking the questions around experimentation and your end user. If this was to happen, how is it that we can learn from it? Are we resilient to it? And we'll touch base on how all of this just kind of gets to come together. I did want to go ahead and introduce myself. My name is Ana Margarita Medina. I am a senior chaos engineer at Gremlin. At the end of the day, I love learning, and me putting this talk together was a lot about that. What are some untraditional ways that I have learned in other spaces that really tie into cloud technologies? I am a self-taught coder. I started coding really early on, and I was developing applications that were online around 2007. And I kept on doing that for front-end technologies, back-end technologies, got a chance to do a little bit of iOS and Android applications. And in 2016, I was that developer that had to learn, where does my code run on? What is this space called ops? And what is this beautiful space that was getting a lot larger and more traction, site reliability engineering? I got a chance to get started in chaos engineering at the same time that I found the space of site reliability engineering. I helped build the chaos engineering platform at Uber around 2016. And now I got a chance to come back into this chaos engineering space as I now get to talk to you all about some of the beauty that comes from it. Representation is something that really matters to me, and I want to give a special shout out to where I'm from. I'm born and raised in Costa Rica, and my parents are from Nicaragua. I believe that if you can't see it, you can't be it, so shout out to all those underrepresented folks in tech. So to bring it back to today's focus, learning, we're going to be talking about different ways that you can learn, different ways that you can experiment in your distributed systems, your microservice applications, anything that you're running in this cloud native world. Hopefully by now you had a chance to think and reflect on the ways that you learn. Maybe you learn very differently than me, and that is okay. Some ways that other folks spend a lot of time learning is by just practicing, getting a handle of how is it that I can deploy a reliable bare bones Kubernetes cluster. How is it that I can set up my EC2s to have CloudWatch alarms? How is it that I can learn all the fundamentals of the cloud and the networking concepts that go with it? How is it that I can build a muscle memory in order for me to get the jobs that I want in the space that I'm really inclined to work in? And when it comes to that muscle memory, sometimes you need to go ahead and build certain routines in order for those muscles to really gain the strength and for you to be able to get better at those skills. And hey, if you're that person that had to burn themselves in the oven in order for you to learn, hey, I need to get some gloves to take out these parts of my food out of the oven, that's okay. I know I had to learn like that many times, and eventually it became a little bit of a muscle memory. So when we bring it back to distributed systems and the technologies that come with it, we know that software and technology is going to break. The world that we're building is continuing to rely on this brittle technology. And now the challenge that we continue to face is bringing that innovation and building products and experiences that our customers are going to love as we minimize that risk of failure as much as possible. if folks are kind of wondering, yes, things break, but that's about it. Well, you have to remember that every time our applications are breaking, it's costing a lot of money. And some of these costs are quantifiable. Sometimes you can't find out how much it's going to cost. And those are those unquantifiable costs. And when it comes to putting together a formula for the cost of downtime for your application, your services, your organization, you can start thinking about the revenue that your company brings in. What is it as part of the code and applications that you work on? Keep that critical path of your application up and running. When we look at that, it comes to that revenue loss, but at the same time, you have to think about the employee productivity that's being lost to deal with this fire. When you talk about the cost after that outage, a lot of it comes back into breaking those service level agreements that folks have with those customers. And when we talk about unquantifiable, a lot of that is some stuff that we can't learn as we're putting this together. This unquantifiable cost really comes down to how much of the brand has actually been damaged because you are continuing to be on the news cycles and folks can't use your services. That also comes to that employee attrition. Engineers burn out. Engineers burn out of always being paged, always being on call. But if you're constantly firefighting and you don't get to work on product and features, you might just be leaving the company and telling folks that this is not the healthiest place to live. That place of work. The average company is known to lose around $300,000 per hour that they're down, and that's not necessarily on their high traffic event or when they're having a sale or launching something new. Think about how much those companies can lose because it's just very, very little that can take for you to go down. And when we talk about these failures, we have to remember that what we're building in the cloud is only getting more complex, which makes it a lot more difficult to operate. The pressure that we have of driving new technologies of infrastructure, application development, architectures, makes it extremely hard. We can take a step back and look at what our legacy applications look like when we were just doing one release an annual year and we only had one service to maintain with only hundreds of servers on-prem. We've shifted left and we re-architected our applications, and we're in this cloud-native world where DevOps has brought us the ability for us to constantly be releasing new code and applications for our users. But now we have hundreds of services that we need to maintain as the microservice architectures just get more complex. And when we talk about bringing containerized environments and technologies like Kubernetes, we now have hundreds of thousands of resources that we need to manage and have resource limits for and have the right constraints. That complexity just continues to increase. And nowadays, we also just want to move fast and break things. But there is a better world. There is a world where you can actually slow down and spend time experimenting, making sure that you're building reliable applications for your customers and your end users. That is that beauty of experimentation. You can do that. And at the end of the day, we're building a complex distributed systems, and there are things that we're going to need to test for, or we are going to suffer that outage. There's some things that you just have to build redundancy on and make sure to test the reliability of it quite often. And that brings me to my favorite ingredient to build cloud native resilient applications, that chaos engineering. We get a chance to dive a little bit more towards the rest of the talk. Chaos engineering is thoughtful, planned experiments designed to reveal the weakness in our systems. This is not about just unplugging servers and saying good luck. This is not about breaking production at all. You want to be thoughtful. You want to plan these out. You want to communicate around the chaos that you're about to inject. And that purpose is for you to make your systems, your processes, your people, your architecture diagrams a lot more resilient, a lot more reliable. When we touch base on chaos engineering, first, I want to touch base on some of the terminology that I'm going to be using. Chaos engineering still has a scientific approach to it. We're going to use a scientific method to go about crafting our experiments. With the scientific method, we get a chance to bring in a hypothesis. What happens to my system when I inject such failure? You want to be really thoughtful when you build a hypothesis. Then it comes to blast radius. Blast radius is that surface of area, that surface of servers, cloud, that you're running that experiment on. That's what you're targeting. It could just be one host, it could be just one Kubernetes cluster, it can be one service alone. That is exactly what you are targeting, and you always want to start small. That other portion of being thoughtful comes with the word magnitude. Magnitude is just that strength of the experiment that you're unleashing. You don't want to start out with a very large experiment because you don't know what you're about to inject. So when we talk about experiments, always keep that in mind. Small blast radius, small magnitude. And then that brings me to the last terminology, abort conditions. This is about a thoughtful practice and making sure you have safeguards in place. Those abort conditions are those things that can happen to your systems that you can see in your dashboard on your application that will let you know this chaos engineering experiment needs to be stopped. Go ahead and halt the experiment. Make sure to always have these things in play before you get started. And when we bring it all back into crafting these experiments, we're going to go through the steps now. The first step is that you want to observe your system. You want to have the architecture diagram. You want to have the microservice diagram that will let you know what is the critical path of your applications. How is it that service A and B get a chance to talk to one another, especially as you're injecting failure into service A and B. Then it comes to understanding the metrics of what you can observe on your system right now. For folks, that also means setting some service level objectives and service level indicators. After we have an understanding of our system under normal conditions, we can go ahead and form the hypothesis. As we form that hypothesis, we want to be really thoughtful. We want to think about those abort conditions that would cause for us to halt the experiment. We go ahead and we define that blast radius and magnitude. I am going to run one chaos engineering experiment on 100% of my hosts where I am just injecting 10% increase into my services. Then we go ahead and we just run that experiment. And sometimes you'll see that when you're running these the first time with your team, you might only get to building a hypothesis and realize, wait, no, I learned something. And that's amazing too. If you do take it to the step of running an experiment, this is when you now get to go back and analyze those results. You have all these observations that you've taken as this experiment is being ran. You analyze those results and you ask yourselves, was my experiment successful, or do I need to go ahead and pull some fixes in order to make my application reliable? If your experiment was successful, you want to go ahead and you want to make that blast radius a little larger. You want to make that magnitude just a little stronger and run another chaos engineering experiment. This is just about always incrementally running more experiments. And that last step is one of the most important steps and one of my favorite steps. It's about sharing your results. Go ahead and share the results of your chaos engineering experiments with your leadership team, with your team, with the community. And when we're talking about building open source technologies and cloud native applications, there's always so much to learn. Go ahead and put a talk together around some of the things that you have learned with doing chaos engineering on a certain platform. Now, I get a chance to show you all how all of this comes together the way that I just explained it. We'll get a chance to do one experiment together. For today's environment, it's going to be a PHP guest application with Redis in the back and running on Kubernetes. This is the tutorial that you see under the Kubernetes website. It comes with a single instance of Redis to store the guestbook entries, and we have other Redis instances that are going to be serving as reads, along with multiple front-end instances for us to be able to observe it. The experiment that we're going to be running today is just shutting down one of the containers for the application Redis. We just want to get a chance to understand when I shut down one container of Redis, I expect that the replica Redis instances that I have are going to continue serving the data that we have. And the work conditions that I'm putting for this experiment is that if I run across a 400, 500 HTTP error, we're going to go ahead and stop this experiment. If our front end has any issues and if we suffer any data loss, the experiment will also be halted. My hypothesis is that when I shut down that Redis container, my application will have no impact and everything will be running smooth. So let's go ahead and just do some kubectl, get nodes to see what is our application running on. We have our 3 nodes that are ready to go. When we do kubectl get pods for all namespaces, we see that we have Datadog deployed, we have our front-end instances, our Redis instances. We've also deployed a Chaos Engineering tooling, and we have some other things under the hood that are just running for Kubernetes. We get a chance to pull up K9. It's a great open source tool that allows for us to just get a better view into our Kubernetes environments. We'll head up to see the load balancer of our application. I get a chance to just submit an entry of my name. I'll now put the margaritas are awesome. Yes, they are. And those are the flowers, actually. They're daisies in English. We'll put in another guestbook entry of someone else dropping by to say hi. One more person is dropping by our guestbook and telling us hello. Actually, they say hola. As we refresh our front end, we see that this data has been saved, and we get a chance to also just go over to our primary Redis instance, and we'll see what the Redis CLI has for info of this current environment setup. We want to understand what the replication of this is. We have this connected to 2 other Redis instances serving as replicas, and that information is being duplicated. So we'll go ahead and just use an API call to unleash an experiment. This should just be shutting down our Redis primary container. Now we'll just reload the user experience to make sure everything is working, and it was. And now it's not. Our entire guestbook does not have any more entries. This is not looking good. So this is that moment when you have to hit that abort condition and you want to go ahead and you want to stop the experiment. So we'll go ahead and do that right now. We had to stop that experiment because we hit that abort condition. That abort condition is data loss. This means that our hypothesis was wrong, but we got a chance to learn that the impact of just losing our single Redis primary container means that we now suffer a data loss. This is completely something that you would have not learned unless you actually suffer a data loss in your day-to-day because your primary Redis container actually had an issue, or you do this by actually just trying to form hypotheses around the mental models that you have of your systems. And this is something so simple. When we think about our containerized environments, the ways that we bring Kubernetes into our infrastructure, a lot of it is because we understand that Kubernetes is going to keep things up and running on a reliable state of matter. But we also didn't get a chance to talk about making sure that our Redis implementation was resilient just from the start. But because sometimes we want to move fast and just get a chance to build, we don't think about some of those failures that can happen. So one of the things that I always say is that if you're bringing in a new technology, a new open source technology, go ahead and just get to test a little bit more of the reliability. What happens if you just inject a little bit more on the resource consumption layer? What is it that happens when you're shutting down those containers? Does Kubernetes bring them back up? Is everything connected already? Are you also thinking about things auto-scaling and making sure to handle that? What are some of these dependencies? Another common topic that I talk around Kubernetes, chaos engineering, is that portion where we want to make sure that we're thinking about the resource limits that we're putting in for applications. And a lot of that comes because when we look at the outages that happen in this Kubernetes space, a lot of it happens because we're not auto-scaling the capacity on our cloud data centers on-prem for us to handle the consumption that Kubernetes can actually have. And a lot of it comes with maybe we also need to just actually implement and validate that the resource limits that we're building on top of Kubernetes are also reliable. So one way you can easily get started with planning and testing your resource limits is by just unleashing resource level attacks. These can be like an increase to CPU, an increase to memory, an increase to IO, to disk, to anything that makes it replicate some of the conditions that will happen as your users are on the website. So you can just start out with a 60% increase and you'll have similar board conditions to that first experiment. If your application stops responding, if you see error rates, the response rates increase, if you have traffic on it and that drop-off rate is really high, you always want to be really thoughtful about those hypotheses. And when it could be that you're actually consuming memory, you go ahead and you think about where else in my system would I see this memory increase. Do you also see it in an increase to your Redis side? Do you see it as an increase to your I/O or your CPU also spiking up? We also have to think about what happens to our applications when we're actually just getting rate limited on an API, or maybe an entire application is not, an entire portion of our application is not working. How is it that we handle that failure? For example, let's say that I have a similar implementation of Redis that I just showed, where we have this as a data store of the items on for our website. And I just want to ask ourselves, what happens if 400 milliseconds of latency are being added to that API call that's pulling those product pages? We have to think about something that can actually happen day to day on our applications, whether it's because the implementation of this API is living on another data center, or that we're actually using a third-party company for this dependency. How is it that our application is going to handle when that resource is having an increase in latency or the resource is just not available? And you want to have some hypotheses around this that would allow for us to think about that latency increase. When that latency increase to this portion of our application, we always want to build it so the application works without any issues for our customers, the end users. And that means that you either have error, like handling on the website for that latency increase, or you also just have thought about a secondary reliable way that you can serve the same experience to your customers. So we are talking about kitchen things, and now I get to talk about the recipe that I have for building reliable applications. We have to start by thinking and talking about always having our applications that are highly available, that we've thought about the capacity and footprint that they're going to be using. And one of the most common things when we talk about cloud native and the failures and being really thoughtful about building these applications is that you want to go ahead and you want to have failover, and you want to make sure that you have deployed to multiple regions, multiple availability zones. For some folks, that means a physical data center and a cloud. And you want to make sure that you have disaster recovery plans in place. and not just have them in place, but that you're going and exercising them with your team quite often. So that brings those things to reliability. We want to make sure that our applications can scale and always be reliable for our customers. But that also allows for us to think about that topic that I talked about earlier, experimentation. We get a chance to ask the questions that the incidents will actually have on our systems, but we get to do this on our own terms. And similar to what I mentioned with disaster recovery, we need to go ahead and we need to practice. That means practice your disaster recovery. Go ahead and look at your runbooks and run them together with your team. And that brings it to just one simple ingredient. Chaos engineering is one way that you can drive a lot of this practice, experimentation, and reliability practices in your organization. Because we are building things in a cloud-native way, in a cloud-native world, our applications are living in such a distributed architecture. So similar to Murphy's Law, we have to think about our applications behaving the same way. Anything can go wrong, will go wrong. Let's go ahead and always assume the way that we're implementing things will break and that we have a reliable way of doing it. And with that, it always comes back to just making sure to practice and break it, and that means that we have to understand the dependencies. We have to understand the defaults that our applications come out of the box in. How does it work on the security level? How does it need to be connected for this portion of my application to actually be reliable? We saw that with that simple Redis implementation. Out of the box, it's not something that is reliable. But if you were to build a little bit more upfront on the Redis side and have things like Sentinel, use the Redis operators, you'll see that an implementation and a chaos engineering experiment being ran across it would have actually made that application be reliable. So make sure to battle test your technologies, go test them before you go ahead and you implement them. And there's that portion of chaos engineering that makes you form a hypothesis, and that's what you all constantly want to be doing. You want to ask what happens when X portion of your system fails, when a certain button of your application is not unreachable. And when you're looking at those architecture diagrams, that is one of the best times to ask questions, and you get to do this with many folks in your organization, from the principal architects that you have, from the senior engineers, and always make sure to bring your your new grad engineers or your interns that you have, so that they can also be learning and build stronger mental models of the applications that they get to work on. You always want to ask your organization, your leadership, what is the work that all of you are doing, so that you're focused on reliability and you're making sure that your day-to-day operations are going smoother. You also want to go ahead and expand that question and ask what work is being done to prevent your last incident. That last incident you had that you may have been in a lot of pain from, you may have had to just be debugging for such a long time. What is the work that is been done since, or that your organization is currently doing, in order to prevent those conditions from causing such failure? And that they're not just your tickets sitting in the backlog for the last 6 months. Make sure to proactively be learning. And you constantly want to take a moment to understand how is it that your system is behaving under normal conditions, so that when that high traffic event, that sale, that new product launch happens, you are able to sustain everything that happens. You want to make sure to always practice, and that practice has various portions of it. A lot of it is questioning things that happen to your systems. You want to make sure to be thinking about the general knowledge and mental model that you have of your application, or what is something that I can learn now, or that I recently learned through my last failure. And with that, I would like to leave you with a nice little takeaway from the chaos engineering community. If you're interested in the free sticker sheet that you see up here, you can head on over to gremlin.com/talk/Ana-chaos-carnival, and you'll get a chance to have one of these sent to your home too. With that, I would like to say thank you for sitting down and watching my talk. Make sure to always reach out with any questions via email at anna@gremlin.com, or you can find me on social media at Anna_M_Medina. I'm always down to talk about chaos engineering, Kubernetes, cloud native space, diversity in tech, mental health. Make sure to reach out. And if you're interested in giving Gremlin Free a try, head on over to go.gremlin.com/Anna to check that out. Thank you all very much. See you all online.
Yeah, so we have few questions on the Q&A section. Anna, would you like to answer them?
Yes, let's go through them.
Yeah. Okay, so Om Kale has also raised a hand. So let me invite him on the stage.
Yeah.
Hey Anna.
Hi there.
So basically, my question is like, are about actions better automated based on the conditions? And basically, like in Litmus Chaos Engine, we have like basically flag to terminate and to like active and stop. So is it possible to make it like automate based on the conditions?
Yes, so like automated chaos engineering experiments that you get to give it, these are the conditions that you abort it with, correct? Yes, so I personally think that's the way you should always be automating. The portion of chaos engineering that's really critical is that where you build a hypothesis, you build those abort conditions, but you make sure that you know how to stop it. So when platforms are enabling you to have that automation piece, you're able to adopt chaos engineering with more of a assurance. And we've also seen in the industry that those are the Fortune 500 companies that we see that are taking chaos engineering and running with it. They already kind of took those quick steps on crawling, on walking, and those safeguards can be like automated as check in an API endpoint if you have any incidents going on, if the traffic rate has dropped so much, if the system already is being worked on, or there's a new deploy coming out in like the next 20 minutes, like there's those safeguards that you can always have. And when we talk about chaos engineering, it's like that I mentioned, the end goal is automation in production, but you need to automate it in all those environments before. So yes, always have safeguards and make sure to look for those platforms that can let you automate it.
Okay, thank you, Anna.
No problems. Great question.
Thank you.
And I think you're on mute, Saranya.
Yeah. So thanks, Om. I hope your question has been answered. So shall we, Anna? Shall we move on to the next question? So we have. You can take a look at the Q&A section.
Yeah, I'm gonna browse them up.
We have a lot of questions.
So we have Ritik asking, the baselining the metric is often an interesting and challenging task. Does it need to be done on a per environment or per service basis to perform relative benchmarks upon, or are these fixed values recognized as service level objectives? So with this one, I also believe that it needs to be a service level objective that depends per service, depends per environment. Every single environment has a different set of customers, and when you're building all these service level objectives, indicators, and agreements, they're really based on what your customer is. So those are not going to be necessarily fixed throughout the environment. I can see many companies adopting where the SLO is a little fixed on staging and production, that it is very similar, like maybe even the same one, so that staging is as close to production as you can be. But the other thing is that when we look at the industry, and I've talked to a lot of organizations, they're also still barely getting started with service level objectives. So it's kind of like sometimes you don't have those service level objectives, and that doesn't mean that you can't start out with something like chaos engineering. Some of those baseline metrics can just be like, what are the normal metrics that I see when when my systems are just running. So some folks call it like steady state, some folks call it normal conditions. It's just, what does my system look like on a day-to-day basis, kind of like averaged out. And that is like, what does your CPU look like? Memory, how many nodes do you usually have up? How many concurrent sessions? How many user base are you going through during a day? You kind of want to make sure that you're not like making that experience worse, and that the only way you can know is by looking at those baseline metrics. I also have OK asking, could you give some examples of scenarios with Redis? So with Redis, it's not that I love picking on Redis, but Redis is one of those tools that we see a lot in the industry. So I've gotten a chance to build a few talks specifically around this. And the data loss example to me is one of those easy ones to show, especially when we see the cloud native adoption just constantly increasing and people are adopting it with much more velocity. And it comes back to make sure that you know how it's going to behave before you implement it and actually tie it back into all your services. So some of the experiments that come with that, first, it's going to depend if you're using Redis as a data store or if you're using it as a cache layer. But when it comes to either one of those, the ways to implement it, you'll see that shutdown will be your number one, in my opinion. Then, because this is serving a lot of data, you want to make sure to play around with the latency. How much latency is able to actually happen? Am I handling all those timeouts properly? If that data doesn't show up on the website, how is that website actually affected? So between those two, it goes back into user experience and data loss, which ends up being part of that reliable user experience that all of this comes together in. We also have other ones that when we think about building global companies on top of serving data on Redis, you want to think about making sure that throughout the networks globally, you're actually able to also have a good experience. So that packet loss coming from Central America, bandwidth there is not the same as the United States. And I see that we also have a lot of folks here from India. And it's like, when we're building a lot of these platforms, we have to keep in mind that packet loss might happen when we are building on data centers in the United States, and we see a lot of folks using our application across the entire globe. And the other one that Redis really grabs onto is memory. So because you don't know how your host is going to behave when you have a memory spike, and a memory spike can easily happen just because it leaks from one of your programs, and that the memory increase on a Redis like implementation is going to actually affect the performance heavily. So you want to make sure to keep in mind, like, performance is going to affect the reliable sense of my entire applications, specifically that user experience. And feel free to cut me off when we're running out of time for questions too. I'm going to continue going down.
Yeah, we have just 3 minutes left. The next questions we can take onto the Slack.
Yeah, do you want me to take the next one more, or no?
We have 2 minutes, so you can take one.
Okay, so the last one I'll take is Sartak asking, what is the best stage to come up with the chaos experiments? Is it the product app design stage? You mentioned deriving from architecture diagrams, for example. This goes back to how mature is your organization. Are you someone that has already built a product? Are you someone that has 100 microservices? And where are you in the organization in prioritizing reliability? The ideal world that I see in this space is that you're actually implementing chaos engineering in that building the MVP, building out that product, because it's easier to do it then than do it 2 years after that has been running. So that would be the biggest thing. But let's say you already have a product out there, you already have 20 microservices, 100 microservices. You can still get started on that, but start out with one service at a time, one team at a time. And at the same time is like, do it every time you're launching a new feature and stuff like it. But it's a whole topic because it really does depend on your organization and what type of services you are offering. For the other questions, I'll make sure to answer them on the Slack channel. But as I mentioned, feel free to reach out on social media or email if folks have more questions.
Yeah, so Rajeshwar, we can move your question to the Slack, and we can, I'm sure Anna can answer there on the Slack one as well. Yeah, so thank you, Anna. It was really a wonderful session. Yeah, so for all of you, do explore other sessions. They are equally amazing. Yeah, so yeah, thanks.